All right, so this is problem number 2, and let's get started. So first, let's just draw a little picture. So we'll have a little car here, and it travels to some final destination. We're not sure that it is. And we know that it does this in 10 seconds. It has an initial speed, well, an initial position of 0, an initial speed of 5 meters per second. We don't know its final velocity, and we don't know its final position. We do know it has an acceleration of 5 meters per second squared. So we want to calculate its final velocity in 10 seconds. To do that, let's just go ahead and use the formula. So we're going to end up getting v equals 5 times 10 plus 5. And that's going to give us a final velocity of 55 meters per second. Now for part B, we want to find the displacement of the car. That's going to be x equals 1/2 at squared plus v naught t plus x naught. So we plug in x equals 1/2 times 5 times 100, because that's 10 squared, plus 5 times 10. When we plug that in our calculator, we're going to actually end up getting 300 meters. Oh yes, and it's plus x naught, which is 0. Now there's a little distinction we need to make between distance and displacement. Displacement, if you remember, is delta x, which is x minus x naught. Distance is the total length traveled. And in this case, the total length traveled happens to equal the displacement. So in this case, we can actually say the two are equal. Now for part C, we want a qualitative graph of the position, the velocity, and the acceleration of the car. All of these versus time. So first of all, our acceleration is constant and positive at 5 meters per second squared. Our velocity starts at 5 meters per second and goes up to 55 meters per second. And of course our position, well, we start at 0 and we move in a parabolic motion. Notice I give it a non-zero slope at the beginning because we're already moving at 5 meters per second at the beginning, so we need a positive slope for that. So that's basically problem number 2 in a nutshell.